Many of the web services that you might work with from within Android might return JSON formatted data instead of XML. And so I've provided a version of my feed that's formatted in JSON. It returns exactly the same data as the XML feed, but returns it as an array of objects. Notice the first couple of characters of this feed. The bracket that starts is matched by a bracket at the end, and that represents an array of content. And then within the array, there's one object for each flower. Each object is notated with braces. And then there are named properties for each of the values. And the names exactly match the names that are used in XML. So now I'll show you how to parse this same content in JSON using this project, parsejson. I'll start by creating a new Java class in the parsers package. And I'll name it flower JSON parser. I'm going to mimic the behavior of the XML parser, so I'll go to that class and I'll make a copy of the signature of the parseFeed method. And then I'll paste that into place here. And then when I press enter, that will add the closing brace for that new method. Everything else about this method will be different, so I won't copy all of the code from the XML version. When you parse JSON, you'll use a set of classes known as JSON object and JSON array. If you know that your JSON content is already coming back as an array, you should start with the JSON array class. So I'll type the name of the class and press Ctrl-space to import it. And I'll name this simply AR for array. I'll instantiate it with a constructor method, and I'll use a version of the constructor method that looks for a string, a JSON formatted data packet. And I'll pass in the content string that was passed into this method as a parameter. Now, that's all you need to do to transform the JSON formatted content into an untyped array of objects. But our goal is to create a list of specifically typed objects, instances of our Pojo class flower. So next, I'll declare a list. Just as before, this is the list interface from java.util, and it will contain instances of my flower Pojo. I'll name it flower list, and I'll instantiate it with new array list. When you autocomplete array list, if you see that the data type flower appears here, that means that your workspace isn't set up for the right version of Java. If that happens, remember that you can go to the Preferences, then to Java, to Compiler, and make sure that your compiler compliance level is set to 1.7 and Use Default Compliance Settings is selected. So far, so good. I've parsed the data into an untyped array, and I've also set up a place to hold the strongly typed objects. Now it's time to do the transformation. The JSON array class does not implement the iterable interface, so you can't use a for each loop on it. Instead, I'll use a standard for loop. And I'll set the ceiling for the for loop to ar.length. But for a JSON array, length is a method and not a property, so I'll add the parentheses at the end. Now, each time through the array, I'll need to get a reference to the current JSON object. So I'll declare an instance of the class JSON object, and I'll name it obj, and I'll call the array object's getJSONObject method, and pass in the index value of I. Next, I'll create an instance of my Pojo, flower, and I'll instantiate it with the noArguments constructor. Now I can deal with each of the data items within the JSON object, and I'll cast each as the appropriate data type by calling a method of the JSON object. I'll start with the product ID. I'll call the flower object's setProductID method, and it's expecting an integer, so I'll call obj.getInt. Each of the get methods of the JSON object class expects a string, the name of the property you're looking for. And so I'll wrap the name of the property in a set of quotes. And if the name that I put in here matches the name of the property in the JSON file, the data for that property will have been passed to the pojo, the flower object. I'll make a copy of that line of code, and I'll deal with the flower name. Instead of an integer, I'll be looking for a string, so I'll call the JSON object's getString method. Now I'll deal with all of the other properties. I'll duplicate this line of code 4 times, and then I'll modify each of the calls. For this one, I'll look for category, and I'll set the name of the property I'm looking for to category. I'll look for the instructions, and I'll set the name appropriately. I'll look for the photo and set the name, and I'll look for the price and set the name. But I want the price to be dealt with as a double value, so I'll call the appropriate method, getDouble. I have a little bit of code cleanup to do here. I'll remove that opening parentheses that wasn't supposed to be there. And then finally, at the end of the code, I'll add this flower to the list by calling flowerList.add, and I'll pass in the current flower object. At the end of the for loop, I'll return the flower list. Now that's all the functional code I need, but you'll see that there are a bunch of errors being displayed. I'll move the cursor over some of them and show that they're all doing the same thing, showing that there's a potential exception called JSON exception. So I'm going to select all of this code, and I'll wrap it with a try-catch block. I'll right-click and choose Surround with Try-Catch. And in the catch block, I'll remove the comment, and then after printing the stack trace, I'll return null. And that's the completed code. So, as you'll see, working with JSON is a little bit simpler if you compare it to the XML pull parser that I was using for XML. The JSON array and JSON object, when they're used to parse JSON content, pull all of the data into memory all at the same time. If you're familiar with XML parsing, this is similar to document object model style parsing. For reasonably sized data packets, it's a great way to deal with JSON. So I've saved that change, and now I'll go back to my main activity. And I have a couple of changes to make here. First, I'll go to my onOptionsItemSelected method that's reacting when the user touches the action bar item. And I'll change the file extension of the feed I'm pulling from XML to JSON. Then I'll go down to the code where I'm parsing the data. That's in the onPostExecute method. And I'll change the name of the class I'm using from Flower XML Parser to Flower JSON Parser. I'll use a quick fix and import that class, and then I'll scroll up to the top of the code, look at my imports, and remove the import for the XML parser. I don't need that anymore. So now I've made very few changes to the main activity class, and all of the changes I've made are in the new class, Flower JSON Parser. And I'll save and run the app in the emulator. I'll click the action bar item, and there's the response. It's pulled the data from the feed, and it's parsed it and turned it into plain old Java objects that I can use for the rest of my application. Now, I'm going to point to something I never touched, and that's my HTTP Manager class. Remember that this is the class that's doing the real work in the background of making the request to the web service and pulling the data down over the web. And notice that this code didn't change at all. From the point of view of Java and Android, text is text. It doesn't matter whether you're working with XML or JSON, you're downloading and saving the content in exactly the same way. And while I'm using my HTTP URL connection code here, I could have just as easily used the Android HTTP client code that I demonstrated earlier in the course. So if you have that much working, you're ready to move on to the next step, which is creating a presentation for this data that looks more like a real e-commerce app. And I'll get into those steps in the next movie.